Solutions and Molar Concentration by Neha and Henfrey. What is a solution? A solution is a homogeneous mixture of two or more substances. So a homogeneous mixture is basically when you can't see the difference between the two components of it. It's all mixed into one. An example of that would be like salt water. So there are two components in a mixture, a solute and a solvent. A solute is dissolved in the solvent, and a solvent does the dissolving to form a solution. There are two types of solutions. A dilute solution that contains a relatively small concentration of solute, and a concentrated solution that contains a relatively large concentration of solute. So I'm going to show you guys a visual aid. This is basically the diluted concentration. This is the concentrated solution in a dilute solution. So you can see that there is not much solute compared to the concentrated one. It's more sparsely. There's not as much as the concentrated one, and that is the difference between dilute and concentrated. There are three types of solutions: a saturated solution, an unsaturated solution, and a supersaturated solution. A saturated solution describes a solution that has dissolved the maximum amount of solute. To explain, a saturated solution would be like a paper towel that has reached its maximum of absorbency. So it cannot absorb any more liquid. That would be like an example of the saturated solution. The second solution is an unsaturated solution. And that describes a solution that has less than the maximum amount of solute dissolved. So carrying on the example from the first solution, a paper towel that has less than its maximum absorbency translates also means that it can absorb more than it has already. So it has less than the maximum, so there's room for additional liquid to be absorbed. The third one is a supersaturated solution. A supersaturated solution describes a solution that has more than the maximum amount of solute dissolved. So again, with the paper towel example, imagine a paper towel that has more liquid than it can absorb. It means like the paper towel is dripping from the liquid because it's more than it can absorb. Now that is an example of supersaturated solution. So I have a graph for you guys. So the graph is basically the solubility curve for the potassium nitrate. This line right here shows the saturated, unsaturated, and supersaturated. As you can see, the more temperature rises, the more solute it can dissolve. So basically this line right here is saturated. For every temperature, this is the maximum it can dissolve. Now I'm going to briefly explain unsaturated again. It's less than maximum. Supersaturated is more than maximum. I'll give you an example of unsaturated. So unsaturated is basically if you were to heat something to 60 degrees and then put 50 grams of the solid in it, it would be unsaturated because the maximum that 60 degrees Celsius can dissolve is about a lot more than 50 grams. So that would be unsaturated. Now supersaturated is the opposite. It is more than it can dissolve. And after it is heated and then cooled, the crystals would form of the additional solid it dissolved or had in its solution. So I have a sort of question about the graph, and it goes: a potassium nitrate solution containing 40 grams at 25 degrees is heated to 55 degrees. What additional mass of potassium nitrate would be needed to saturate the solution? So first we have to find the coordinates of the 55 degrees. So you can see that the solution is saturated, so we look at the line. So we go to 55 degrees, which is approximately over here. And we see that the saturated solution would be around here, which would approximately be 80 degrees. So I would write that down, 55 and 80. And then our second one, which we already given the coordinates to, 25 and 40. When you can see that it is on the line of the saturated curve. So x is 25 and y is 40. So it's very simple. You basically just minus the y values because we need to find out what's the difference. So to explain what the additional mass would be needed. So we just minus both of the y values. 80 minus 40 which I hope you don't need a calculator, is 40 grams. The second example is a potassium nitrate saturated solution is heated to 70 degrees and it is then heated to 85 degrees. What additional mass will be needed to saturate the solution? So just like the first example, you need 2 points. So for the first one, let's see, heated to 85 degrees and it's a saturated solution. So we look at 85 degrees and it's approximately 160 grams of solid. So we get our X value is 85 and then our Y is 160. And then for our second one, it is a saturated solution heated to 70 degrees. So 70 is right here, and approximately it's solid that it dissolves is 120. So again, 70 is our X and our Y is 120. So again, just like the first one, we see the two Y values that contribute to solid because they're the solid values. And then you minus them. 160 minus 120 gives us, very easy math, 40 grams. So you will need 40 grams additional grams to saturate the solution. Molar concentration is our second topic. So what is molar concentration? Molar concentration is the number of moles of solute that can dissolve in 1 liter of solution. The equation for that is molar concentration equals amount of solute in moles over volume of solution in liters. Very, very important, your units. So the first example is, what is the concentration of a solution that contains 0.7 moles of sodium chloride in 400 milliliters? So first, let's write out our equation. Molar concentration equals the amount of solute in moles, don't forget your units, over volume of solution in liters. So you can see that 0.7 is our moles, so it's already given. We don't have to calculate anything. And our volume is given, but it is given in milliliters. So first, to convert it into liters, you have to do the simple calculation of 400 over 1,000, which gives us 0.4, because there is, for every 1 milliliter, there's, you guys know. So you have to, in the brackets of molar concentration, you should write your formula. NaCl equals amount of solute, which is given, 0.7 moles, over the volume, which is 0.4. Put that down, 0.4 liters, which gives you, if you guys do the calculation, I'll give you guys a second to calculate it. And I'll give you the answer now. It is 1.75 moles per liter. As you guys can see, I just divided it, and that is my answer. So the molar concentration of sodium chlorate is 1.7 moles per liter. That's our first example. Our second example is 4 grams mass of sodium hydroxide is dissolved in 5 milliliters of water. What is the molar concentration? So what we are given is the volume, and what we're also given is the mass of sodium hydroxide. As you can see, it says 4 grams. So what we need is the moles, and that is it, because we already have the volume of it. But it's also in milliliters, so we have to convert that. Let's convert it first. So 5 over 1,000 gives us 0.005 liters. And now to find moles, you guys know this formula. It's mass over molar mass. So I already have the mass calculated, but if you have to calculate it, you guys can pause the video and then come back to it. So we are given the mass, which is 4, and the molar mass, which I've calculated, is 40. So when we divide it, the moles are 0.1. So we already have the volume and we have the moles. So we just put it into our equation. And our equation, I'll just write it again for you guys, is MC, molar concentration, equals amount of solute in moles over the volume of the solution in liters. Volume of solution in liters. So molar concentration, we put in our formula, which is sodium hydroxide, NaOH. The amount of solute, right here, the moles, 0.1 moles over our volume, which is 0.005 liters. So when you calculate that, so I'll give you guys a second to calculate it. The answer is 20 moles per liter. If you guys can see, I just divided it. That's it. That is our answer. And for our last example, it's a little bit harder. What is the volume of the solution if the molar concentration is 8.2 moles per liter, dissolving in 11 grams of sodium hydroxide? So what we are given is the mass of sodium hydroxide, and we are given the molar concentration. So this is different than our traditional formula, and our traditional formula is MC, molar concentration, equals the amount of solute in moles over the volume of the solution in liters. So first let's figure out the moles, because no, actually first let's rearrange the equation. So we need the volume and we have the molar concentration. So what we do is we have to switch it. You would have to take it onto the other side and do a lot of math stuff. So our new equation is volume equals amount of solute in moles over the molar concentration. So I've said before, we have the molar concentration, we need the volume, and we need the amount of solute, but we are also given the grams of sodium hydroxide. So we find the moles. Again, you guys should know how to find it. It's mass over molar mass. So I already have the molar mass, but you guys can pause the video if you guys don't have it and you want to figure it out. So the mass is 11 grams, and the molar mass of the compound is 40. So again, you divide it. Very easy. 11 divided by 40 is 0.275. So we have 0.275 moles. Then we put it into our equation. Volume equals amount of solute, which is this, 0.275 moles, over our molar concentration, which is already given to us, 8.2 moles per liter. So we divide this, cross this out, and our volume is, I'll give you guys a second to calculate it. Our volume is 0.03 liters. So as you can see, I just divided it. Very easy. So that is the end of our lesson. I hope you guys learned something and have a great day.